page here. I said we're going to come back to this. Flip the page on the note guide. It says rational exponents on top. Now what we're dealing with is, what if we have the situation now ready, Lozano? The word rational is just a fancy schmancy word for a fraction. So next to rational, either on top or on the bottom, go write fraction. That's just a fancy word for saying fraction. So now we're dealing with exponents that are fractions. How do we deal with that? Well, I kind of already introduced you to how to deal with it. Let's get it a little bit deeper now. So this is how we deal with it. If you have a to the m over n power, look at what ends up happening. The denominator becomes the index. Look at this. It's the index, and we already know that. And look at the numerator becomes the power that it's raised to in the end. Look at what the number. The numerator becomes the power that it's raised to, that everything's raised to, and the denominator becomes the index of the nth root. That's all you got to remember. The numerator of the fractional exponent becomes the power. The denominator, we already know, becomes the nth root. We've already practiced with the denominator. Up till now, I've just been giving you fractions like 1 over half or 1/3, where the numerator is always 1. Now I'm going to throw fractions at you where the numerator is not 1. It's actually numbers like 2, 3, and so on. Any fraction, in other words. So you have a little note section. Let me give you a few examples. What is 8 to the 2/3 power? All right, simplify. 8 to the 2/3 power. Notice it's not just 8 to the 1/3 now, it's 8 to the 2/3 power. Let's see, let's evaluate this puppy. Let's follow the pattern. What does a 3 become? What's that word? It starts with an I. It becomes the index. So look, I'm going to put 3 here, and let me put 8 inside the radical symbol. Let me put parentheses, and then the 2 becomes the second power of everything. Right, Burns?
I didn't even get one of those papers.
This morning? I got you. Look at the pattern. We already know that becomes the index. The only new thing I'm throwing at you now is that the numerator becomes the power that everything's raised to. So let's try this. Let's do this. Let's see. Here we go. Taking notes, Simon? Are you getting cold feet now? Sure. All right, let's do it. Yeah, so let's do what's in the parentheses first. Remember, please excuse my dear Aunt Sally from junior high school days. You always do what's in parentheses. What is a cube root of 8? 2, huh? Thinking 2 times 2 times 2, it becomes 8. If you're bad at mental math like me, just type in your desmos.com, cube root of 8, it'll slap you 2. Okay? So I got really then 2 to the second power now. Notice how this all became just 2. So let's 2 to the second power. Right, 2 times 2 is 4. So the final answer is 4. Right, it looks a lot scarier than it actually is, right? If someone were to walk in this class and knows nothing about math and you're doing exponents with fractions, it's going to give them nightmares. But now you know, look at the numerator just becomes a power, the number becomes the index. Big deal. Start another one. Let's go 27 to the 4/3 power. 27 to the 4/3 power. Jim, you with me, right? Are you watching movies? That's cool. Follow the pattern. Medina, what does the denominator become? What's that word that starts with I?
No. No.
I-N. I-N. Nice. That's a whole number.
Index.
The index. So the 3 becomes an index. Beautiful. 27 goes in the radical symbol. Beautiful. Let's put all that to the numerator's power, the 4th power. We're rocking and rolling. Cube root, or the 3rd root of 27. 3 to the 4th power. 3 times 3 times 3 times 3. I'm really bad.
81.
Are you sure?
Yes.
Positive. Put that on everything.
Yes.
Okay. Three times 3, 9 times, yeah, 27. 81. Okay, cool. We're good. All right. We're done with those notes for now. Now notice the bottom section. All the way at the bottom, right here, it's number 7 through 12.